This is another episode of the Flat Earth Conference Debunked. You will notice that flat earthers really only have one argument for their flat earth belief. It looks flat. That's it. That's all they have. They do not actually have a working flat earth model that explains any real observations, passes any tests, or makes any accurate predictions. They don't even have a working map. So instead of actually trying to prove their belief, they usually resort to trying to poke holes in the scientific evidence for the spherical Earth and the heliocentric model, as you're about to see. At the recent conference, a group of flat earthers that call themselves the GlobeBusters tried to bust many scientific facts. In this episode, I will cover their claims about the moon. Will their claims hold up to scrutiny, or will it just be more lunacy?
Some of the incongruencies that we have, additional incongruencies I should say, with the heliocentric model would be, first up would be the moon, okay? We're told in the heliocentric model that the moon is basically reflecting the light from the sun, and it goes through different phases, depending on what angle it is to the sun. That's how we get our different phases throughout the month. But the one thing that I want to focus on primarily is what happens on a full moon. Now, we've all seen a full moon. We've seen the harvest moon. We've seen it gigantic. We've seen it all different sides. We've seen many photographs of it. And when the moon is full, it is absolutely brilliantly bright, and it is lit evenly, pretty much evenly from the center to the edges. And in fact, really, the edges seem to be a little bit brighter. For the most part, at least in most of the moon photography that I've done. But what you really need to do is you need to think about that for a minute. It's like if you were to take a flashlight and you were to point it at a basketball or any type of a ball, what would you see? Well, what you would see is you would see at the front of the ball, the sphere, something like we're showing right here, you would see a hot spot, okay? The very brightest part would be right in the center. And beyond that, you would see a diminishing light going back towards the equatorial region, okay? We never see that with the moon, and that is a huge incongruency. The lighting of the moon simply cannot be caused by reflecting sunlight. It just makes absolutely no sense. There is no law of physics that explains that, and that is a huge incongruency.
So Bob Nodal wants us to point a flashlight at a basketball to test what the sunlit full moon should look like. But he doesn't show us a basketball, he shows us this 3D rendering of a smooth, shiny ball. So let's look at a basketball in bright, direct lighting. It is a bit brighter in the center and darker toward the edges, but much less so than his digital ball. Basketballs have somewhat shiny surfaces, so they do show some variation in the lighting across the surface, and even a bit of a hot spot, depending on the ball's surface and the lighting. But the surface of the moon is not like the surface of a basketball. There is more to consider than just the shape of an object reflecting the light when determining what it will look like. We have to look at two other things: its smoothness and its reflectivity. A very smooth surface, as seen on these billiard balls, reflects light at steep angles back to the source of light, resulting in a bright hot spot, and it gets darker toward the edges. This is called specular reflection. More commonly, we would just call it shiny. And in case you're not sure what that is, here are two other examples of dense objects exhibiting some shiny specular reflection. But rougher surfaces reflect light differently, as they tend to scatter the light in all directions, like these unpolished stone balls. This is called diffuse reflection. You can see there is no hot spot, and almost no darkening toward the edges. This is more like the moon. It is not smooth and shiny. The moon is covered by a powdery dirt called regolith, which reflects the light very diffusely. In fact, the moon's regolith is so diffusely reflecting, it is described as Lambertian, which means you see very close to the same amount of light no matter at what angle you view the surface. So this explains why you don't see variation in brightness from the center to the edges, and the moon appears as if it were a flat disk. And additionally, the moon has very low reflectivity. The moon is actually quite dark in color. An object's color and texture affects its albedo, which is a measure of how much light it reflects. The albedo of the moon is actually quite low. It is only 0.12, meaning that it only reflects about 12% of the light that it receives. This is about the same albedo as old asphalt or dark wet soil. In contrast, the Earth averages an albedo of 0.37, which is about 3 times brighter. With such a low albedo, any subtle variation in light reflectivity of the moon due to the varying viewing angle between the center and the edges becomes even harder to see. So once again, flat earthers fail because they are willfully ignorant of science, leading them to have incorrect expectations. And as you're about to see, their flat earth belief is so poorly defined, and it is so useless for explaining any observations, that they cannot even agree with each other about the most basic facts.
I would still argue, not to be like a devil's advocate, but I would argue that moonlight being reflected sunlight may actually be the case. I mean, it's not incompatible with the notion of a flat Earth, but I mean, it does bring up a good point. Although, in reflected light, there could be some of that energy absorbed by the moon and other, frequencies of that energy reflected. But just wanted to mention that because that is a point of contention for a lot of people, or at least when people say that, the moonlight couldn't possibly, and this goes all the way back to Zetetic from the 1860s. Even Robotham argued that moonlight couldn't possibly be reflected sunlight because, it's a cooling light, it has putrefying effects as opposed to, moonlight has putrefying effects where sunlight has preservative effects. So there are different properties between sunlight and moonlight, but I think it is a bit of a leap to say that therefore, moonlight couldn't possibly be reflected sunlight because to me at least, there is a lot of evidence that the moon's phases are somehow correlated to its relationship position to the sun. But
yeah,
my 2 cents.
Yeah, and you'll find that, obviously, straight up, I disagree with that, but that's okay and you'll find that there's a lot of thought and conjecture about, the nature of things and amongst flat earthers. And that's, mostly because we don't have a $52 million a day budget to go and research on this. So what we're presenting to you today, at least in our opinions, is common sense. And in my mind, common sense tells me that if I shine a light on a ball, it's going to have a hot spot and it's going to diminish back towards the back. Now, a lot of other flat earthers have said that the moon is a self-lighting source. And if you want to look at that biblically, God created the 2 great lights in the sky. He doesn't say anything about the moon reflecting the sunlight or anything like that. They're supposedly their own individual lights. So there's obviously several different perspectives on it, and that's why you will not always get 2 flat earthers agreeing on the same model.
I love to listen to 2 flat earthers argue about who is more wrong. John the Morgile, and this is the first time I've ever said this about him, is right that the moon reflects sunlight. Of course it does. Reflected light of the sun perfectly explains all moon observations, particularly the phases, and the idea of the moon generating its own light is patently absurd. There is no mechanism that could possibly cause the moon to self-generate the phases in sync with the sun's position, while leaving shadows in the craters. But he's also wrong when he says it is not incompatible with the flat Earth. Of course it is. There is no possible positioning of the sun, moon, and an observer that could even result in a full moon on a flat Earth. Think about it. A full moon requires viewing the moon from very nearly the direction of the sun, but that is impossible on a flat Earth. If the moon were only a few thousand miles above the surface, and only a few thousand miles away, as they claim, then you would never view it at an angle that is close enough to the light source for it to look full. And that angle would drastically change throughout the night as the moon moves over your head. And furthermore, if you could see a full moon in the northern hemisphere on a flat Earth, then the moon would be close to a new moon phase at the same time when viewed from the southern hemisphere on the other side of the flat Earth, since you would be looking at it from the other side. But of course, we never see that. The moon is seen in the same phase in all locations on the Earth in the same day. So they both are demonstrably wrong in different ways. In fact, observations of the moon are devastating to the idea of a flat Earth, as I've explained before, which is why they desperately try to refute it. And anyone can make these observations.
Okay, so next thing up that I want to talk about is eclipses, I think, are a problem. Now, one of the biggest arguments that we get from globe believers is, how do eclipses work on a flat Earth? Well, there are several schools of thought on that, but I think what we want to start out with first is looking at why the heliocentric eclipse model is unrealistic, okay? And if you look at this diagram here, basically what it's showing is it's showing the sunlight coming in at straight lines, to the moon, but yet the shadow is focused down to a very small point, okay? Now, last year, I think it was August of last year, we had the solar eclipse. Myself and my family, we all went to Nebraska to see the sun eclipse in its totality. And one of the interesting things that they told us that was predicted and verified by us with our balloon that we launched was that the umbra would be about 70 miles. Now, if you don't know what the umbra is, that's the part of essentially totality, the very darkest part. Then there's supposed to be what's called a penumbra, which is kind of a twilight zone. But we never really actually witnessed a penumbra. We saw a shadow, an umbra, and then back to daylight.
Okay, Nodal shows he doesn't understand why the shadow of the moon during a solar eclipse is smaller than the moon. He doesn't even understand the illustration he is using. This is because he leaves out a critical fact: the size of the light source. The sun is about 400 times bigger than the moon. So let me illustrate why that results in a small shadow. The sunlight is not just a single beam of light going in one direction like a laser beam. You have to realize that every part of the sun generates light that beams out in every direction. So picture each spot on the sun sweeping out a wide swath of light, not just a single beam toward the moon and Earth. During a lunar eclipse, the light from each part of the sun is blocked by the moon at a slightly different angle, as illustrated in this animation, which of course is not to scale but illustrates the concept. You can see that because of the different angles of the light coming from different parts of the sun, the net result is a cone-shaped shadow, the umbra, between the moon and the Earth, in which none of the sunlight can directly get to. And this also explains why there is a penumbra, which is a region which is blocked from some of the direct sunlight, but not all of it. By the way, I watched last year's solar eclipse in person also, and I definitely experienced the penumbra. From the time the moon starts to partially block the sun, from our perspective, you are in the penumbra, and the sky gradually gets darker during that time as the umbra gets closer and more of the sun is blocked. I really don't know what Nodal was expecting to see, but it was obvious to me and the other people around me.
But the interesting thing about that is if the moon is only casting a 70-mile wide shadow on the Earth, then logical thought would make you wonder, well, if you turn that around and we're looking at a lunar eclipse where the Earth is supposedly blocking the sunlight from the moon, then you would expect to see something on the order of about 4 times that size. It's a little bit less than that, of a shadow on the moon.
Wow, no, that is not how it works. You cannot just multiply the moon's shadow by 4 to get to the size of the Earth's shadow. That is a gross oversimplification. Yes, it's true that the Earth is about 4 times bigger than the moon, and the distances involved, of course, are about the same in solar and lunar eclipses. But the angles are different. the relative sizes of the Sun and Earth and the relative sizes of the Sun and Moon are very different. So the angles of the sunlight are very different. His so-called common sense analysis ignores the angular differences. The Earth's shadow, when it reaches the Moon in a lunar eclipse, is exactly as predicted by the distances, sizes, and angles involved. This unique composite image of a recent lunar eclipse shows the size of the whole shadow relative to the Moon. Sorry, Nodal, but your common sense is not good enough for science. You have to look with better eyes than that, understand the geometry, and sometimes you have to do the math.
The Globers will tell you, well, the mathematics all works out for it, but they're basing that math on these type of angles, which are absolutely unrealistic. This is not how shadows are cast.
Astoundingly, Nodal admits that the math works out, but he prefers to go with his flawed intuition instead. I have rarely seen a more blatant admission from a flat earther that they are not doing science, but rather they are trying to support a belief system by attacking science. Yes, the math works out when you understand it and you get the distances, sizes, and angles correct.
In fact, most of the time, we all see if you have a light source and we're casting a shadow, I'm seeing my shadow now, the shadow is typically bigger than the object that's casting it.
Again, when the light source is bigger than the object, the shadow can be smaller than the object. They just have never tried it. But I did, and it's easy to do. I used this photography light and a small plate. You can see I drew the outline of the plate on this paper, and as I moved the plate away, the dark part of the shadow, the umbra, is definitely smaller than the plate. You can easily try this yourself. You just need a light bigger than the object casting a shadow. So again, this explains why the moon's shadow during a solar eclipse is smaller than the moon.
But there's been a few times where during solar eclipses, the shadow of the moon on the Earth was less than 2 miles in diameter, which really begs the question, how is an object that's supposedly, 1,000 miles, they say, in diameter, or radius or whatever, for the moon, how is it possible for an object that large to cast a shadow that's only 2 or even 50 or 70 miles in diameter?
Yes, this is true. The size of the moon's shadow does vary a lot in different eclipses, because the moon's orbit is not circular, but elliptical. So the varying distances result in varying shadow sizes. In fact, when a solar eclipse occurs when the moon is near its farthest distance from the Earth, called apogee, the umbra does not even reach the Earth, and therefore we see an annular eclipse instead of a total eclipse, in which the moon does not entirely block our view of the sun. Again, when you include all the facts, it works. And let's not forget, they have no explanation for any of this.
I took this quote directly from Wikipedia. And of course, like you said, the Seleninian, God, that's hard to say for me, eclipses occur when both the sun and the moon are above the horizon in the sky. They're rare, but they absolutely do happen. So the mainstream explanation from Wikipedia tells us that they say, although the moon is in Earth's umbra, both the sun and eclipsed moon can be simultaneously seen because atmospheric refraction causes each body to appear higher in the sky than their true geometric positions. And to that I say, BS alert, BS alert. That is absolutely preposterous. That there is no way that you would get that type of refraction, especially looking up, up in the sky. There's just nothing about that makes any sense. And again, you have to research a little bit into atmospheric refraction to understand why that is absolutely impossible.
Whenever flat earthers bring up the Seleninian eclipse, in which both the sun and moon can be seen at the same time above the horizon during the eclipse, they always leave out a critical fact. Are you starting to notice a pattern here? They leave out that it only occurs for about 2 to 9 minutes before the sun or moon sets, and only if you are viewing from just the right location. Indeed, it is caused by atmospheric refraction. Both the sun and moon are just above the horizon when this occurs, so the light is traveling through the atmosphere at a very low angle, which is well known to frequently cause refraction effects. Nodal says it cannot happen when looking up at the moon. But you wouldn't be looking up. You would be looking just above the horizon, and the refraction allows both the sun and moon to momentarily be visible at the same time. Okay, there is more of this, but I think I've covered enough for one video. The most astounding thing to me is that this team of GlobeBusters freely admit that they do not have a working model that explains any moon observations. And yet they are sure the heliocentric globe model is false. No, there is only one way to debunk science, and that is with better science. I think I have conclusively shown that that is not what they are doing. Thanks for watching. Please check out these other Flat Earth debunking videos. And remember to like, share, and subscribe.